In the last video, I taught you how to factor by the sum product rule, and that applies to expressions that have the form x squared plus bx plus c, where b and c are integers. In this video, I want to talk to you about how to split the middle, which is the last factoring technique I think you need to know, and that applies to expressions that have the form ax squared plus bx plus c, and we generally use it where a is not equal to 1. Notice that if a is equal to 1, we could use this strategy, x squared plus bx plus c. In order to factor by splitting the middle, you actually need to understand the other strategies that we've talked about. Splitting the middle involves factoring by grouping, and it's very similar to the sum product rule. If you can do those two things correctly, then you can split the middle. Here's an expression that I'm going to factor by splitting the middle. The first step to split the middle is to multiply your ax squared term and c. So I'm going to multiply these two. The product that we get from multiplying these, in this case 10x squared, is the product that I care about, and the sum is going to come from 11x. Here's what I mean by that. Again, I'm looking for two numbers that multiply to the same thing, that multiply to 10x squared, and add to 11x. So now I'm back to trying to use something similar to the sum product rule. I need things that multiply to 10 and add to 11. Well, things that multiply to 10 are 2 and 5, or 1 and 10. If it needs to add to 11, then 1 and 10 are my numbers. Splitting the middle, though, involves taking that middle term, the 11x, and breaking it up. So I'm going to write the expression now as 2x squared, and I'm going to break up 11x into x and 10x. So 1 and 10. Well, if you know how to factor by grouping from here, you should see that we can factor this expression in these two groups. The greatest common factor from the first expression is x, and that leaves us with 2x plus 1. The greatest common factor from the second expression is positive 5, and that leaves us with 2x plus 1. Whoops, let me get my colors right. So now, since I have 2x plus 1 in both of my expressions, I can factor that back to itself, 2x plus 1, and I have to multiply that by x and positive 5. I factored the original expression, 2x squared plus 11x plus 5, by splitting the middle, factoring by grouping, and that's what got me to the factored form at the end. Let me do another example. Let's try factoring 6x squared plus 19x plus 10. Since the coefficient of the x squared term isn't 1, I have to try and split the middle. So I'm going to multiply my ax squared by the c term. Whoops, and I guess I should include the plus 10 in there. That gives me 60x squared. I'm looking for the two numbers that multiply to 60x squared and add to 19x. And I know that they're going to both have x in them, so I'm really just thinking about multiplying to 60 and adding to 19. So you might already know the numbers, but one way to think through them if you're not sure is just to list all the factor pairs of 60. So 1 times 60, always start with 1. 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10, and I think those are all my factor pairs of 60. And I need the two numbers that multiply to 60 and add to 19. So which two of these add to 19? Well, 4 and 15. So those are how I'm going to split the middle. I'm going to split 19x into 4x plus 15x. And it's plus because I need them, these are both positive numbers. If one of them had to be negative, then I would have maybe put a minus by it. All right, and I'm going to copy down the rest of the expression. 6x squared plus 4x plus 15x plus 10. Okay. Notice that this expression is still equal to the one up here. I've just split this middle term, which allows me to factor these two groups. In the first group, the greatest common factor is 2x, and that leaves me with 3x plus 2. And in the second group, the greatest common factor is 5, and that also leaves me with 3x plus 2. Well, since now these two expressions have a greatest common factor of 3x plus 2, I can factor that out, and I end up with 3x plus 2 times 2x plus 5. Okay, so I wanted to review really quickly what we know about factoring now. We know how to factor the greatest common factor and by grouping. We can always factor, or we can always try to factor expressions with the greatest common factor. And we can sometimes factor by grouping. Usually that's when there are 4 terms. The sum product rule applies when there are 3 terms, with the leading coefficient of x squared equal to 1, and splitting the middle applies when we have something other than 1 at the beginning. Okay, in the next video I'm going to show you sometimes when we have to put multiple techniques together to factor.